Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we look at application development and management at scale. Teridion is the sponsor for this week's episode of the New Stack Analysts. Teridion provides cloud-optimized routing with a rethinking on network performance and the traditional content delivery network. You can learn more about Teridion at teridion.com. Hey, it's Alex Williams, the New Stack here for the New Stack Analyst Show. This week we are talking with Elad Rave, co-founder of Teridion, and joined by Kris Lahiri, co-founder of Egnyte. Teridion is an interesting company. I'll get back to them in just a minute. But first, I just wanted to also introduce my co-host, Joab Jackson, managing editor of the New Stack. Hey, Joab.
Hello.
You know, one of the things that we've been researching over at the New Stack is really about this continuum in the market that we're seeing. You know, we've gone from bare metal and the emergence of the Linux kernel way back when to this time now, you know, with the maturity of virtualized infrastructure, configuration management, and integrated platforms and tools. What's interesting is right now we're seeing with these new advancements have come the deeper need for integrations. And now we find containers as the heir to this next generation of application architectures. But in the midst of all this changing reality about ways to think through how systems are managed, we're starting to see something happen. You know, nothing really ever goes down anymore, but that's almost worse in some respects because we see this curse of widely distributed infrastructure where latency and data congestion, and you have all these other issues that can come up, really, which can create these monsters in the data center and real headaches for the end user. And so what we're seeing increasingly is this quest for better performance. And without that great performance, a business really can slow down, as we all well know. And time is spent really waiting instead of meeting the demands of a market that really can be unforgiving of slow and late responses. So Teridion is a sponsor for this week of the New Stack Analysts, and Teridion provides a modern take on traditional CDNs, which don't always perform really as expected. They offer rethinking on network performance to deliver dynamic content across the internet. We're lucky to have Teridion's co-founder Elad Rave today, and also joining us is Kris Lahiri, the co-founder of Egnyte. And Egnyte's a company I've known for a long time, and they're a real leader in this new world that demands ways to anticipate IT and end users' need to securely, easily, and intelligently share content stored on premises or in the cloud. Kris is responsible for Egnyte security and compliance, as well as core infrastructure, including storage and data center operations. Welcome, everyone.
Thank you for having us.
You're very welcome. So I would like you to just tell us a little bit more about Teridion. Can you encapsulate what Teridion does?
Sure, Alex. What Teridion does, with lack of better words, we make our customers' internet about 20 times faster. We're a modern take on CDN, where we both see the same problem. However, CDN realized that the way that they're going to help with this problem is cache content on the edge, which is great if you have static content and anything that can be used for CDN, basically. Teridion's take was different, and we said let's try to figure out how we solve the problem. And the problem, both CDN, we all see the same problem. That's not the issue. The problem is with routing, how the routing is done on the internet. And Teridion's take was that let's look at the modern solution for this, not something that will just ease the pain, but something that will actually solve it. After a long time and a lot of testing, we developed a way to do this, and we leverage cloud resources, and I think we're the first company who does network in the cloud and leverages public cloud infrastructure for networking purposes. And when we do that, we overcome the routing issues on the internet, and by doing that, we allow companies to have 20 times better performance, both upload and download, and pretty much any type of content, not only HTTP.
What do you mean by leveraging cloud resources?
So cloud started as a platform for CPU and then for storage. It was never meant for networking. It actually still is not meant for networking. So we developed a way that allows us to use cloud resources, basically to deploy resources in the cloud, virtual machines, basically, cloud servers and different cloud providers, and leverage those resources to do networking and routing decisions. Before that, you had to put a huge amount of hardware on different locations and just to pour a lot of money into this. And this also enables us to be very, very agile and very, very cost effective because we own no infrastructure of our own.
Okay. You know, that brings up a lot of issues that we see playing in today's market. And, you know, you provide some context for what the technology offers here. There's all kinds of issues, you know, I think which you touch on, you know, how do you deploy this next generation CDN really by leveraging those cloud resources? How do you know, better the end user experience? What are the ways to deploy networks in the cloud? You know, for example, if the internet was really never designed to serve that purpose. So there's any number of real-time issues such as scaling up or down, you know, so on and so forth. You know, Kris, you know, with these issues in mind, you know, what is this new internet like for a company trying to deliver the best, most optimized service? You know, how do you guys trace that challenge? I mean, I'm curious on how you trace that challenge back to your first days, you know, in starting the business and thinking through like how you're going to create this, like really this distributed network that you have across cloud services in your and private data centers. So can you tell us about the progress of the company? You know, when you started to feel the pain of this new congested world, you know, what was happening? Just would love that context for how, you know, for what I think what Elad had to say and kind of these other kind of pressing issues that really almost anyone in the market faces as developing some enterprise scale operation.
Well, yeah, thanks, Alex. Thanks for having me on, and good to be here with Elad. Actually, everything that Elad said and what you were saying is very contextual to a company like Egnyte. Egnyte's in the enterprise file services space. We really provide a platform to large enterprises, small enterprises, in order for them to do a lot of things with their files. It's more like a collaboration platform, a sharing platform, things that our customers end up doing for, you know, just their regular day-to-day life. Now, in terms of progress of the company, and where we started to feel the real need for a performance booster in that sense is as we've been working with large enterprises, almost everybody seemed to have multiple offices. And in today's day and age where everybody is interconnected and they have offices around the world, we see that many offices or many of these customers of ours end up having satellite offices all around the world, where their internet connection may not be, you know, what we are expecting from, let's say, a metro place like the San Francisco Bay Area or New York or something like that. So as Egnyte's grown and our customer base has grown, we've seen the need where, let's say, someone in Southeast Asia or in Australia or a small office of our customer have performance issues in just working with their files and applications, so much so that it becomes a productivity deterrent, you know, while all the benefit of moving to the cloud and a decision made in the corporate office, let's say, helps the company in general. We feel the pain of these smaller satellite offices around the world where it's taking them a long time to deal with, let's say, large files and other interaction of doing things in the cloud. So here's where we as a company started looking at different things, you know, and as you would think in the startup world, we tried to come up with our own solution, which ends up being very similar to what Teridion does, where, you know, we start to leverage, let's say, public cloud infrastructure in different parts of the world to what we call this as network acceleration, you know, in order to accelerate the speed at which these satellite offices work. But then when we came across Teridion and started doing more work with them and also started, you know, working across a few different customer sites as a live test, we started noticing, you know, that there is a significant improvement in what Teridion provides. And it's also something that they work on. So it was a good decision on our part to kind of offload that challenge and let the folks like Teridion handle that. But going back to your main point, as the company is growing, as more people across the world are getting onto the internet and using cloud services to consume everything, this is a new congested world, as you're saying, and assuming that everybody in the world has the same level of access to the internet is completely incorrect. Mobile devices have their own speeds, and satellite offices in different regions have their own speeds. So it's a very relevant and an important topic for us to address for all our customers.
Elad, I'm curious, from your perspective, you study this really, deeply, and the state of this internet traffic jam that we see out there, and how Teridion works as this cloud traffic router. Can you explain what that means and and how it might work for a customer like Egnyte?
There is a problem with the way that the internet works. I have a 100 megabit internet connection at home, and it's a very, very good day if I get an actual 10 megabit. If that was the case and there was no problems, and none of us would have buffering in YouTube or Netflix, and we all do that. We all have that. There are a few reasons for this, but the main thing is that there are congestions on the internet. Just like when you drive from one place to another, there are traffic jams because there are only so many roads that you can take, and there are only so many decisions. Because unlike the regular roads, most roads on the internet it's a one direction road. It's not a bidirectional, and so if you want to move from, if I compare it to the roads, if you want to drive from San Francisco to Los Angeles, you cannot go back. You always have to move, southwest from San Francisco to get to Los Angeles. You can never move east or north in order to improve your route. And then, those all new car navigation software like Waze came up, and they look at the entire picture and they say, hey, why, if you take this little thing, it might look like the road is longer, and it might be a longer, might put more miles on your car, but you will get to your destination sooner.
Well, let's take it down an abstract level of abstraction. Now, this is what the Border Gateway Protocol, BGP, was designed to do, is to kind of even out the traffic across the internet. How are you guys doing better than BGP?
So that's correct. BGP was supposed to do this, and BGP can do this on a what's called a private network or a managed network. However, when you use the internet, you move from a lot of providers, and BGP is a very old protocol. It's over 40 years old, actually. It was never designed for the scale it is right now. BGP tables are very, very limited, and the way that they implement it, in order for it to survive on the internet, on the public internet, is this information about congestion is not being shared between routers. So a router knows it can send traffic to any other of his adjacent routes. Usually what happens these days is that it selects what's called the least cost routing. The router, the link that costs least for the ISP, because the ISP doesn't make any money off of it. They don't charge you per gigabyte, the ISPs of the internet that run the backbone of the internet. And so in theory, you are absolutely correct that a BGP can do it. But realistically, with the size of the internet and how many routers and different providers and different links and different hops and different ISPs, it cannot work. And for this reason, routers are not aware. They can send you down to a link that maybe 3 hops ahead of it, you'll have a major congestion or a lot of jitter or latency. And that router, when it made that decision, is not aware of the entire route end to end.
So you guys talk about these virtual routers, right? Can you explain what these virtual routers are and how they're deployed? And I was reading up a little bit about how you do this without installing software or plugins. I'm curious about that.
So the virtual routers are our flavor of network routers. However, they don't run BGP. They run our proprietary technology. Our proprietary technology allows those routers to communicate and make a decision that is a more of a global scale. So in our case, our routers can see the entire route end to end and make the best decision. Not only that, but another subsystem that we have, what we call the TMS, the Teridion Management System, has an overall look of real time, of the state of the internet in real time. And we leverage this data to a very agile pre-routing of our customers' data to always provide the best available route.
I've heard folk tales of Google doing something similar of their own traffic, like all of a sudden half the U.S. Google traffic gets routed through Brazil because at that moment that's the most efficient route, and nobody knows how Google makes these decisions. But I'm kind of curious, how do you do the Waze thing? How do you sample each of the spots, and how do you crunch the numbers, and I guess how close to real time can you offer your customers?
Two parts of this question. First of all, Google does it because Google owns their own intranet. So they own all their lines. So basically Google create their own internet, let's call it the GoogleNet. And when you own everything, you can make BGP work for you. They actually use BGP for that. And BGP can do this. If you have a limited, managed, finite amount of hops that is under all of them under your control, you can do it. The internet, however, is not that. So they can manage everything that goes on the GoogleNet, but once it gets to the public internet, it's out of their control. But they can get as close to the end user as they possibly can. And that's one thing that Google does. As far as how do we get all the information of the internet, what we do is, first of all, we have a couple of thousands of Teridion Cloud Virtual Routers, or TCRs, spread around the world in different cloud providers already for our customers. So we have a lot of data because most of our customers, I think by now, we pretty much cover all the locations of the world, maybe with the exception of Antarctica. But there could be some cases where there are potential locations in the world where we don't have enough information. In that case, our system, our TMS, our management system, figures out if which cloud provider or cloud providers, in plural, have data centers in that location. And then it deploys a cloud server on these cloud providers and runs what we call the TMA, the Teridion Measurement Agent. It's a system that runs for about an hour and maps the internet and investigates the internet behavior at that location. Who are the ISPs? Just basically sends our proprietary measurement protocol and measures all the behavior around it. This information is being sent to our big data analytics, and we have what's called a streaming big data analytics that all the time crunches out numbers and figures out what is happening on different locations in the world, and enables our system to paint sort of like a heat map of the internet, where the green zones and where the red zones and the yellow zones. And at any given moment, we can make traffic go only through the green zones and never through the red zones. So hopefully that answers your question.
Awesome. Yes.
Yeah, that's interesting. So, back to Kris. How does this work for Egnyte? Can you give us some use cases and examples? Based on what we just heard from Elad.
Yeah, actually, a lot of that is what Elad said is very pertinent to what we've seen. Consider, for example, we've got a customer out of New York who has an office in South America, like Argentina or Brazil or someplace like that, where they, in those offices, probably are having the best network connection that's available in region. Now, when we've analyzed a few concerns or performance issues that were raised by, let's say, these offices, we would find out that, the first hop out of their office is always pretty good. That last mile connection is fine. But somewhere along the way in getting from, let's say, Brazil to our data centers, the network route was always going down, let's say, one path, right? And now neither Egnyte through our ISP nor the customer through their ISP seems to have any influence on this intermediate route. And all of this ended up being a lot of back and forth and discussions and all of that, which is when we realized that while BGP is making the right decision closest to that endpoint, there is some other thing at play, especially when you're going across continents and all of that, that you aren't able to influence. If we were able to influence, let's say, the network end to end, then I'm sure there could be other things that we could improve. But for a cloud service provider like ourselves, that's not our core business, right? We are not looking at trying to optimize network routes around the world and all of that. We just need this to work for our customers. And when someone like Teridion comes in and then figures that out for us, we are kind of happy to let that work out. Now, what happens is, from my perspective, I need the ability to onboard my customers very easily. I don't want to involve, let's say, customers, network engineers, or other people there, right? Because that's a huge roadblock and other things in terms of just getting this benefit out to the customer. So onboarding people onto this, let's say, network acceleration is very important to someone like me. And secondly, I need the ability for this thing to learn itself. Like, for example, let's assume that Teridion finds a better network route for this customer in Argentina, and that works fine in the first few days. But there may be other congestions or something that comes up, and I need a system which would then figure out maybe an alternate route that goes through a Texas or a Houston or something and comes to us. And if there's this other system that is constantly learning as, let's say, usage pattern changes across the internet in different parts of the world, as, let's say, new service providers come online in other parts of the world, if there is someone who is constantly looking out for that and improving on that, that's a huge advantage to us. And I feel that also is one of the main things where we find that a traditional CDN is very different, because in a traditional CDN, they rely on their infrastructure. And as a result, they are also liable to the same problems that might arise on their infrastructure. Whereas in a Teridion case, since they are agnostic of who are the service providers, one day they may go through a provider one, since that provides the best route for us. Another day it goes through some other provider, and it's completely transparent to both Egnyte and our customer. And we just make sure that the customer is seeing the best benefit out of it. So that's how this is working out, for Egnyte customers, really.
Now let's take a quick break before we get back to the second half of the show. We'd like to thank Teridion, our sponsor for this week's episode of the new Stack Analysts. Teridion does something different than most traditional content delivery networks. They offer what they call cloud optimized routing. It's this way to really route around the traffic that is just growing at such a scaled out rate across the internet. You can learn more about Teridion and how they have a different take on networking performance at Teridion.com. Now let's get back to the show.
Hey, I'm kind of curious about the potential user base. I got the feeling that this could provide an alternative to running a wide area network, but there's also the traditional CDN market of you might have a global audience for your content, so you want to you have many users. Who is your market audience base for the service? And also, you had mentioned something about static content, and how can you address the needs of more dynamic content?
CDNs are very, very good for serving bits from disk, and you can only cache static content. You cannot cache API calls. You cannot cache my Facebook feed, because my Facebook feed is different than your Facebook feed or Twitter or what may. You might be able to cache an image, but that's the best you can do, and it doesn't solve the problem. And also, CDNs are only one directional. You cannot use CDN for uploads, for example, where Teridion can, and it's only limited to HTTP and to HTTPS if you give the CDN the SSL certificate. Teridion is a different approach. We're a network solution, so we do this on an IP level, not on an application level. We don't cache, and we allow bidirectional both upload and download. It works for everything from API through voice over IP, WebRTC, uploads. Kris might share that one of the things that Egnyte has in their feature is the ability to use FTP. I don't know of a CDN that supports FTP, whereas Teridion does. Another interesting thing that we do, as we serve an advertising agency that has ads on the internet. There's no way any CDN can work from them. It's all API, very, very small calls, very, very dynamic. So without Teridion, with the best thing they could do, they would get their ads to display in about 1 second, which is great. If you ask ad networks, they'll be happy with this. Once they use Teridion, now they can display their ad in less than 300 milliseconds. And that's overwhelming in this market. So this brings a lot of, when you actually solve the problem, then we look at CDN as a really, really good thing, but it's a painkiller. It's not a solution to the problem. And also, another cool thing that we do with Teridion, and hopefully Kris can maybe share more information about this, about his experience with this, is our customers get what's called mid-route visibility. So if there is an issue on the mid-route, for example, for one of Kris's customers, leveraging Teridion can actually help even figuring that out.
Kris, I had a question really for you about, security. You deal with, very sensitive data from your customers. How has that worked for you at Teridion? How are you able to, make sure that, for your own customers, you can assure them that their information is secure?
Security is really front and center for a company like Egnyte, and since we are primarily an enterprise file services provider, it's very important for our customers. And going back a little bit to what Elad said about caching, right, and how CDNs do this, most CDNs are, let's say like a layer 7 type cache, where they actually need us to distribute, let's say, our SSL keys so that they are able to cache this content on the edge. And then we need to trust them in terms of we really delegate that security to that CDN provider, and we are expecting that they are doing the right thing, right? Which in most cases they are, but you now have suddenly increased the surface area of an attack that some hacker or someone could be looking at to a much wider area, which is not even under your control. So one of the most interesting things on the whole Teridion technology was that this is a layer 3 type protocol, which does not really care about what you're moving. It looks at the network layer, and it's able to route traffic at that layer 3, and hence it's agnostic to whether it's HTTP or HTTPS or FTP or what is that protocol. And as a result, we are able to accelerate. Not that we use voice over IP, but within Egnyte, we are able to accelerate any type of traffic, including FTP and HTTPS, which seems to be our main protocol. So from a security standpoint, that's a huge and a very important consideration on our part, because now I know for sure that even though network or data is being routed through, let's say, different public networks or other providers around, there is no data access that's possible anywhere around there because no SSH keys or no certificates or anything like that had to be distributed. And it's really just bits and bytes that are getting routed. So that was one very big consideration as we were discussing the Teridion technology and how sensitive we have to be to just overall customer security on this. Secondly, changing the topic a little bit, going back to that mid-route visibility, while on one hand, we would really like a solution where we don't really have to worry about what that underlying technology is. We just know that customers are seeing better performance when we use Teridion, and that's really all we care about. But in some cases, especially in some cases where there are other, like regional outages or some other such things that end up happening, what we've seen is that we are able to influence, because of the visibility of mid-route congestion in some place, we are able to influence that route, or I should say Teridion is able to influence that route to go through some other place, which by the normal BGP algorithms or anything else, that route would not have been the most preferred route at that time. But in case of certain regional outages or other things that we've seen, if a customer complains in a specific region, we kind of bring that up to Teridion, and through their own visibility, they are able to make that influence. And both the customer as well as Egnyte comes out happy at the end of it, and we really didn't have to do anything about it. So that's a important consideration to have as a partner. Traditionally, if we didn't have something like this, what would end up happening is we go back to service providers who would pretty much shrug their shoulders and say, there's nothing we can do about it. It will resolve itself when whatever was that issue in mid-route gets resolved, whether it's faulty equipment or something else. So that has helped. Not that this happens too often, but it's comforting to know that when it does happen, we do have something that we can influence and hence have a happy customer at the end of the day.
How is interfacing with Teridion different than interfacing with a CDN in terms of what do I need to do to my networking stack to prepare for this? It sounds like I would need a lot more servers than I would need if I was just going with a CDN. Is that correct?
The answer is no. It actually requires nothing on the customer's edge, and we know one of the things we hear from our customers that the ease of getting on board Teridion is really good. They literally they do not need to install any software, any TCP stack, any hardware. They do not need to do anything, and it's pretty much automated by Teridion once they sign up with us, and once they do this, the magic starts to happen. It does not require more servers or anything like that. I mean, Kris is here on the call. He knows if they had to increase their servers. Hopefully, they needed to increase it because they had more clients, but I don't think that because of Teridion.
So how do you get to that point? So how do you start using the Teridion service?
Well, if I can quote somebody, we spray pixie dust. There are a few ways to start using the Teridion Cloud virtual routers. It can be anything from actually adding another route to your router, which is not really relevant because most businesses run in the cloud, so they don't own their own routers. So in order to support that, we actually looked at how do CDNs do this. And CDNs do this by a simple CNAME change. So we decided to support the same methodology. So we support the same methodology like CDNs do, where you do a CNAME change, and then Teridion takes over. A little bit more complicated in our end because we need to support both upload and download. That's what Teridion does. The customer, all they need to do is to do a CNAME authentication, and pretty much from that point on, it's on Teridion.
Does that become your biggest challenge? Is that almost that balancing between that upload and download, being able to balance it across your own virtual network, across those virtual routers. It seems like that would be one of the big challenges for you guys.
So balancing between upload and download is not really anything that is challenging for us. Running the router is, but once the server is acting as a router, then it could care less if it's uploading or downloading traffic. It's the same thing.
But then how you distribute that across your own network?
So each router, just like any public router, can act both for upload and download. However, one of the unique things we do is two things. Our smart routers allow us to do something what we call reverse load balancing, which means we will never create congestion on our network. It cannot happen that our network will be congested. That's one thing. In order to do this, sometimes a connection to Egnyte, for example, can come, an upload can come from one TCR, but the upload will come from another TCR. But that's not necessary. The system is very agile, very automatic, so things change literally within minutes.
So maybe you can clarify that a little bit more on reverse load balancing. What is the reverse in this, in what you described here?
So reverse load balancing. Let me give you an example of driving. I live on the East Bay. Our office is in San Francisco. When everybody turns on their car navigation, 7 a.m. in the morning, it tells everyone go through the the Bay Bridge because it's clear. Everybody's starting to drive. Everybody gets to the Bay Bridge. They're all getting there together, and now there's congestion. If only I could tell some of the cars go different times or different routes, eventually everybody will get to the city faster, excluding Super Bowl weekend, which is this weekend, but in general terms. But you cannot do this with cars. However, we developed a technology that allows us to not only spread the packets on different routes to make sure that they always get that the overall performance is increased, but also to create virtual Bay Bridges. So instead of one Bay Bridge, you might have 3, 4, or 10 Bay Bridges and send traffic over there, even if it didn't exist before. I wish it could be done in a physical world. It will allow a lot of traffic to go through at that specific time. And then when this time is done, when it's over, then we delete all those virtual routes or virtual Bay Bridges in that case. And we can do this very dynamically, leveraging cloud resources.
So I have a question then, based upon that. So you create these virtual bridges, right? And so you could create any multiple number of virtual bridges. What happens when everything starts getting connected? It's not just cars anymore, right? So it's any possible node you can imagine, right? The desk here that I'm sitting at can be a node, right? The microphone can be a node.
Yeah.
How do you scale out I always think of it like it's the urban architecture of the internet, right? So like, how do you scale out the bridges and not just the bridges, but like the rotaries and the intersections and everything else? It seems like that just becomes a reality of it, of what can happen in a scaled out world that we're in.
You're absolutely right. And when you look at the IoT, that's going to be worse and worse over time, or harder to do over time. So this is where the magic of cloud comes into hand. If you think about this, if you had a regular website and you had more and more visitors, you would actually have to plan ahead and figure out, I'm going to have 50 million users a day and calculate how many servers you're going to have and build it. And most of the times you'll only have 2 million users a day, but you just plan on having $50 million. So you pay a lot just in case. And God forbid, if you have 60 million users, you might be happy, but your system would crash. Mm-hmm. So then came cloud and basically said, who cares how many users you have? If you build your infrastructure and your software the right way, then it scales accordingly. So we did the same thing for network. So we leverage cloud to help us do network, stuff that routers used to do. It's not an easy thing to do. Cloud was never meant to do that. So scaling up and scaling down, that's part of our core technology on how we do this. But that enabled us to create very unique situations when we can send traffic from one cloud provider to another, and then back to a third one, and do a lot of weird, I would call that network structures or graph structures that were not existing on the regular physical internet. On a virtual world, you can do plenty of things you cannot do on the physical world, and that's exactly what Teridion does. If you want to compare it to virtual Bay bridges.
I could ask a dozen other questions here. This is really interesting. Maybe my last question here is, can you just tell us a little bit about the infrastructure itself? What is that technology? What is that technology underpinnings that you're developing and that you've built? I mean, I know it's proprietary technology, but just give people an idea of like what this infrastructure stack, so to speak, looks like for the cloud service that you've built.
Well, actually, it's elegantly simple. We just use VMs in the cloud that run our software, and what we understand is communication is key. And if you don't talk to your colleagues, you're not going to achieve your goals. And if routers don't talk to each other, they're not going to make it work. If somebody in the audience wants to get more understanding, we have a reference article posted on the Teridion website with the architecture that might give more of a visual understanding of what we do. But it's a very elegant solution. The critical things is how do you scale up and especially how do you scale down? Because unlike HTTP, TCP is stateful. So we had to develop. We have some really, really smart people who worked this thing and figured it out and how you do this on cloud providers. And not only that, but a cloud server is not made for networking. If it pushes 100 megabits per second, that's a very, very good one. We needed public cloud servers out of our control to push, over 500 megabits per second. And so that was another technology that we had to develop on how do we do this. And again, without touching the data, we're not, compressing anything. We're not, injecting anything to the data. As Kris mentioned, it's SSL end to end.
So that's when you would leverage AWS and Azure and other services then?
Yeah.
Okay.
Yes.
Great. Well, I think that about covers it for today. Elad, I want to thank you very much for participating. And Kris, thank you as well. And to my co-host, Joab Jackson. We look forward to keeping in touch with you all about the developments at Teridion, and Kris, look forward to keeping in touch with you about the progress that you're making over at Egnyte. And I'm a big fan of you guys, and Vineet Jain's is a colleague. It became a friend of mine in my older days over at TechCrunch and such. So please tell him I say hi, and I look forward to meeting everyone here again soon. So thank you very much.
Thanks, Alex. Happy to be here, and I'll definitely convey your regards.
Thank you, Alex. I'm also happy to be here. Thank you very much, everybody.
Okay, thanks a lot, guys. We'll talk to you soon. That's it for this week's show. Thank you very much for joining us. We'd like to thank Teridion, this week's sponsor of the new Stack Analysts. Teridion is a bit different than most traditional content delivery networks. They offer what they call cloud-optimized routing, something that's becoming increasingly needed in this day of increased congestion across the internet. You need to get your content to places quickly. You need to send it on the route right and in a secure manner. Teridion offers a different take on network performance, something that you don't really see with traditional content delivery networks. You can learn more about Teridion at teridion.com. Audio editing and sound design for the new Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. www.stackanalysts.com. Thanks again, and hope to see you back at the show. Bye-bye.